Hello guys, so in this lecture we're gonna continue discussing about diode clipping, and I'm gonna do the negative clipping in two ways now. So we explored negative clipping, but in a fast pace we can say in the last lecture, but we're gonna go into deep into it because it has similar but opposite characteristics basically to positive clipping. Okay, of course, the obvious characteristic is that that it's make the clipping and the negative half cycle. But even in the analysis itself, it's much more deeper than this. Okay, so I'm gonna solve this circuit, this simple circuit, in two ways. In this video, I'm gonna explore a very fast way, although it's more smart. And in the next video, I'm gonna, in a long time, I'm gonna explore another way, but it's more deep, much more deep, okay? And you will understand it, we can say 150 or 200%, because I'm gonna convince you that really when much more details, that really when we reach some point or some level in the input, the diode will be off or on, reverse or forward, something like this. Okay, so let's start by the smarter way, we can say, okay, in which we explore just like what we did with the positive clipping or the last lecture basically, is to find the V input minimum. Also a caveat here, it's not V input minimum, okay? You can name it in some way, in another way, as we will see later, okay? So I'm gonna start by the same kind of analysis I did before. So again, if this is zero, this is a ground here, so this is zero, so voltage is zero. Here VB is flipped in that way. Let's assume it's 4 volt, and V maximum here, for example, is 10. So this is 10, this is minus 10. Okay, so the voltage of that point is minus 4. Why? Because when you say that the battery is 4, that means that the positive is greater than the negative by 4. Okay, and when the positive is 0, because the positive here is connected to the ground, then the negative must be minus 4. So 0, which is positive, minus 4 will give you 4, which is the value of the battery, VB. Now look at the diode. The diode has the B terminal connected to minus 4. So in order for that diode to conduct, this node here must be minus 4 minus or minus 4.7. Why? Why? Just subtract them from each other. You want, when the diode conduct, the voltage is to be in that way, negative positive equal to 0.7. That means that the B is greater than N by 0.7. Good. When you subtract, minus 4 minus 4.7 will give you minus 4 plus 4.7 will give you 0.7. Okay? And here is the caveat. In the other, in the circuit, remember the diode was flipped. The B was here and the N was down in the bottom. So we needed to increase the input to exceed the input minimum. Remember, guys, the input minimum that we talked about last time. Okay, so that's the diode conduct. Here, no. Here it is the opposite. Here we need the input to be less than minus 4.7 so that the diode conduct. So here it is opposite stuff, it is really opposite in many things, but in the same way we can say, okay, here instead of saying that the input should exceed the input minimum to so the diode can be on, can turn on, here the input should be less than minus 4.7, which is the input minimum, now our new the input minimum now, so that the diode can on, although it's not minimum. Okay, this is basically here, this minus 4.7 is the maximum value that the input can have and the diode can still be on. So in order for the diode to conduct, V input must be less than or equal minus 4.7. Or in another words, this is basically minus VB, guys. So if we just, because I don't like numbers, just make it in symbols or parameterized, we can say, so that you can, if the number changes, you have the concept, you have the main equation. So this is minus VB, and this is basically minus VB minus 0.7, which is minus 4.7 in that special case here, because we assume that VB is equal to 4, just to put some numbers to feel it. Okay, so let's apply this. So if we say this is, for example, the minus 4.7, and let's take a line here. Let's apply what we are taking, what we are stating here. We said that when the input is less than or equal to minus 4.7, the diode will be on. For example, minus 5, minus 6, or minus 10. So basically, in that area here, from that point to that point, from that point to that point, all these values are less than minus 4.7. And the diode in that area will be on. So the diode is on here. Other than this, the diode will be off. So basically, from that point to that point, the diode is off. And also, in that small region here, the diode is also off. Only here, the diode is on. Okay, so let's state that, and let's see what would be the output and the input. So number one, let's make it a bracket like this. Number one, when V input is greater than minus 4.7, or generally minus V minus V minus VB minus 0.7, the diode will be off. So the current is 0 and VR is 0. Let's make Kirchhoff. This is V input here. This is VO. And this is VR. So you see that V input equal to VR plus VO. VR is 0, so VO is equal to V input. Now let's check number two. When V input is less than or equal to V minus 4.7. So when V input is less than or equal to minus 4.7, the diode will be on. So VD all the time will be 0.7. Now let's check VO. If we look at VO here, look, VO is in the same way of, or the same rotation, as VB and VD. So by Kirchhoff here, VO plus VD plus VB equal to 0. So VO is equal to minus VB minus VD. In that case here, VD is 0.7, and we know that VB is minus 4. So this is minus 4.7. What is this? This is, our new V input minimum, or it should be V input maximum. This is the maximum value that the input can take, and still the diode is on. When the input decreases, or goes down or below minus 4.7, decreases than minus 4.7, the diode will start to conduct. Okay. So this is the first, the first parameter here, or the first unknown. Now the second unknown, which is VR. Again, V input equal to VR plus VO. So VR is equal to V input minus VO. So VR equal to V input minus VB minus 0.7. I'm just putting it in the parameterized way, or V input plus 4.7. Let's draw that now. We need to know where the input is greater than V input maximum, okay, or minus 4.7, and when the input is greater or less than the minus 4.7. And we said that, so from that point here to that point, all these values are greater than minus 4.7, and also in that location. Okay, what happened when the input is greater than minus 4.7? VR is 0 and VO is equal to V input. VO equal to V input, so just copy and paste V input and V output. So when V input is 0, this will be 0. And for example, here 1, this will be 1. Here it is 10, this will be 10, and so on. Just copy and paste. Okay, so I'm gonna copy this triangle here into VO, just like this. So basically that one, that triangle is basically that triangle. Let's shade it. So guys, you know what I'm talking about. Also, still this portion here. So I'm gonna also copy this one into here. And this point is minus 4.7. And again, this portion should be copied and pasted to the output. And it's again minus 4.7. Now for VR, it is really simple. It is just 0. Very simple. Now, let's do the on. And again, just not forget, this portion here is exactly that one, and that one is exactly that one. Now, when V input is less than V input maximum, V output is constant equal to minus 4.7, or V input maximum, or V input maximum minus VB minus 0.7, which is exactly that point. So here is the range from that point here to that point. Here is the range in which V input started to decrease than V input maximum, minus 4.7. So at that case, VD or V output, I'm sorry, will be equal to constant equal to minus 4.7. And again, that portion, if we highlight it in that way, like this, is exactly that one. How about VR? So VR is V input plus 4.7. Whatever V input is, add to it 4.7. So for example, here V input is minus 4.7. When you add 4.7, it will be 0. So let's check. Yeah, it's 0. You should continue from what you ended by. So we end by 0 here, so we should start by 0 as well. And again here. So again, here is minus 4.7. If you add 4.7, it will be 0. Again, you should start from what you ended by. And pretty much the same for that triangle here. Remember, all these values here, if we look at this triangle here, it's like a triangle under minus 4.7. So if you add 4.7, this triangle will move just above by 4.7. And this point will be minus 10 plus 4.7, it will be minus 5.3. So basically, you will have this triangle exactly the same for VR. Let's check the dimensions. It's around 2 squares, something like this. and this is minus Vmax plus 4.7 or minus 5.3. That's why it's minus. And again, that triangle, as we said, is exactly that one. Now look at, VD or V output and VR. And again, by Kirchhoff, guys, if you take this red, shape and just attach it to the blue shape here, it will be something like this. And it will give you exactly the input. Okay. So again, the trick here is to find not the input minimum, but the input maximum. Same concept. Okay. But with the positive clipping circuit, when the input exceeds that point, the diode will start to be on. Exceeds, I mean increase than this point. That's why we call it the input minimum. The minimum input required to turn the diode on. After which the diode will be on. Here it's the opposite. We need the input to decrease to turn the diode on. Okay. We need the input to decrease because basically the positive of the input is connected to the N portion. Okay. So we need it to decrease so the diode can start to be on. So now we will call it the input maximum. The maximum voltage at which the input can still turn the diode on. After which, if you increase then this the input maximum, if you increase, that will be off. Or if you decrease then the input maximum, if you go below this the input maximum, that will be on. Okay, that's basically how to solve such a circuit. Okay, in the next video, we're gonna take a long time to explore the other approach. Okay, but you can solve with any of them. Both leads to the same result. So don't worry. You can work with this or this. But personally, the second one, I prefer it because it's deeper. It's easier to understand. Just go away from this V input minimum and V input maximum, and we're gonna use it again when we talk about rectifiers, the second most important applications for diode circuits, as we're gonna explore it in the next lectures. Okay, guys. So thank you very much for watching this, and see you in the next video. Bye bye.